Hi, I'm Tom for GM-Trucks. At this year's Consumer Electronics Show, I focused on the Advanced Driver Assistance Sensors, or ADAS, needed to bring you Super Cruise for your Hummer EV, as well as even more advanced sensors that'll be used for Cadillac's Lyriq and Celestiq. According to General Motors, Ultra Cruise employs cameras, radars, and LiDAR to develop its 360-degree, three-dimensional statistical representation of the surrounding environment. Here are some of the demonstrations we saw, including raw data shown on laptop screens. We'll begin with LiDAR, as Ultra Cruise incorporates an integrated LiDAR behind the windshield.
Hi, I'm Eitan Gertel. I'm the executive chairman of OPSIS. OPSIS is a new generation LiDAR company. We developed the first in the world scanning LiDAR using semiconductor devices only. The advantage of this LiDAR is it has absolutely no moving parts, and it's still a scanning LiDAR, which means it can optimize on the longest distance and the highest resolution. In addition to that, because we are a semiconductor base, we are scanning at 1,000 frames per second. And as we deliver data to our customers at 30 frames per second, we have time to basically average our data and clean up our data. So with the signal processing, we get to our users basically best reliability data they can have for the autonomous driving. So effectively, you have what's called the probability of detection for the full range of the LiDAR above 90%.
A problem with most of the sensors on vehicles, including and especially cameras, is if people are hidden behind objects or emerging between vehicles, they can't be seen. Or they can't be seen in dense snow, fog, or glare, making safe driving very difficult. Long-wave infrared sensors can detect the warmth of a child or adult between roadside vehicles through blinding sunlight, and it can also see beneath a modest blanket of snow to detect lane markings, which makes it another valuable tool to integrate into ADAS, Advanced Driver Assistance Systems.
So I'm Bill from Atasky. I'm the head of North America for our operations. We developed a thermal imaging sensing device that can see in total darkness, inclement weather, fog, rain, and glaring headlamps and sun. And in a very interesting use case, it can see through heavy dust, which is very important for like off-road truck, Baja racing. We're getting a lot of interest from the automakers for that. This device is very small, low power, easy to package on the outside of the vehicle. We're talking to many OEMs for application for high volume production. We've won a production program with a major US OEM. We're also looking at it for aftermarket applications in the sport utility market and certainly off-road market.
As most of you know, radar has been the basis for adaptive cruise control, that set and forget system that will, in some cases, bring you to a stop behind the vehicle in front of you. It's time for an upgrade to what we have, one that uses technology similar to a modern F-35 type fighter, which is a Loonwave antenna. Operating in the 76 to 81 gigahertz band, this tiny Death Star antenna is capable of high resolution up to a 360-degree field of view and a detection range of over 300 meters.
Yeah, good morning. This is John Shin, co-founder and CEO of Loonwave. We're a machine-based radar, high-imaging radar company. It's the biggest problems, twofold, in today's automotive radar. One is it doesn't see enough clarity. So my analogy, take out my contact lens, getting behind a vehicle, that's today's radar. Everything is blurry. Certainly not good. Second is the tunnel vision. So today's radar sensor, the field of view is very limited, about 10-15 degrees right in front of the radar. It gets the distance and the clarity, but outside of that limited field of view, distance detection as well as clarity gets significantly worse. So in short, for Loonwave, because of the Loonwave antenna technology, we provide the industry with industry-leading performance by ways of seeing the farthest about 2x of the traditional radar and seeing 5 times more clear than the traditional radar. And perhaps more importantly, it's that uniform performance across a very wide field of view. So to the consumers, I would say it's the benefit of feeling much safer, being much safer in the vehicle, because we're developing the eyes of the future vehicle.
Finally, let's look at a problem I've personally encountered: sensors covered with mud, insect debris, or ice. We'll show you a potential solution based on proven technology. This device was developed by the British consultancy TTP and is being commercialized by its partner Texas Instruments. It's an ultrasonic method of driving debris off a sensor, shown here at 2,000 frames per second.
Hi, I'm Tom Jellicoe. I'm a technology consultant from TTP. We're a company based in Cambridge, UK. So we solve technology challenges for companies developing sensors for autonomous vehicles. There's been a lot of innovation in sensors over the last few years, and this has allowed a bunch of new cool features in cars, things like lane keeping assistant for highway driving and adaptive cruise control. But one of the challenges is that the sensors that allow these features often become caked in sort of dirt and grime and dust when they're used in adverse weather conditions. So we've worked on a technology which can keep these sensors clean by using ultrasound to remove dirt and liquid from the sensor. So what I've got behind me is a video of this technology in action. So on the bottom you can see the cover for a sensor for an autonomous vehicle. And when we apply ultrasound to it, it starts to atomize and remove liquid and dirt. We're hoping this will be available in vehicles in 3 to 4 years' time, and hopefully this will make some of those autonomous driving features much more robust.